Good morning everyone. Welcome all of you in online classes conducting by St. Paul School Class 7 Science classes. So students, today we are going to start Chapter 6 Physical and Chemical Changes. In our daily life, we observe many changes around us. These changes can be observed by us at home, school, playground, parks, and other places. For example, ice melts on heating, water boils on heating, iron rusts in moist air, common salt dissolve in water, vegetables and pulses change on cooking, and milk changes into curd. Similarly, burning of wood or matchstick, change in weather, etc. are some other changes. Among all these changes, some changes can be reversed, whereas some cannot be reversed by reversing condition. So students, in this chapter we are going to study about these type of changes. Every day you come across many changes in your surroundings. These changes may involve one or more substances. For example, your mother may ask you to dissolve sugar in water to make a cold drink. Making a sugar solution is a change. Similarly, setting curd from milk is a change. Sometimes milk becomes sour. Souring of milk is a change. Stretched rubber band also represents a change. Make a list of 10 changes you have noticed around you. In this chapter, we shall perform some activities and study the nature of these changes. Broadly, these changes are of two kinds, physical and chemical changes. So students, all changes as we have studied above example, among all these changes, some changes can be reversed, whereas some cannot be reversed by reversing the conditions. So the change which can be reversed by reversing the condition is known as reversible change. For example, stretching of rubber band, glowing of an electric bulb, melting of ice, etc. Reversible changes are temporary changes. The change which cannot be reversed even by reversing the condition is called irreversible changes. For example, aging of living organism, rusting of iron, burning of paper, cooking of food, growth of plant, burning of fuels, etc. So irreversible changes are permanent changes. So in this chapter we will study the nature of these changes, and broadly these changes are of two kinds, physical and chemical. So let us start with the physical change. One activity is given, that is explaining the physical change. Activity 6.1. Cut a piece of paper in 4 square pieces. Cut each square piece further into 4 square pieces. Lay these pieces on the floor or a table so that the pieces acquire the shape of the original piece of paper, and you have to observe the figure 6.1. So students, what we have to do in this activity, we have to take a square sheet of paper and cut it into 4 square pieces. Then cut one square piece further into 4 square pieces, as you can see in the figure 6.1, and arrange all these pieces on a table so that the pieces acquire the shape of the original piece of paper. You cannot join the cut pieces of paper to make the original sheet of paper, but each small piece of paper is still paper. It has no changed into something else. So the cutting of paper is a physical change. Activity 6.2. Collect the chalk dust lying on the floor near the chalkboard in your classroom, or crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Roll it into the shape of a piece of chalk. Let it dry. Did you recover chalk from the dust? So, One more activity is given, that is activity 6.3. Take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sun. You have now a mixture of ice and water. Now place the tumbler in a freezing mixture, ice plus common salt. Does the water become solid ice once again? Yes, obviously. So by these activity 6.2 and 6.3, what we can say? We can say that some changes are reversible. So the change that occurred during the melting of ice to form water can be reversed easily by freezing the water to form ice again, and no new substance is formed. So melting of ice and freezing of water are temporary and reversible. Thus they are physical change. One more activity is given. Boil some water in a container. Do you see the steam rising from the surface of the water? Hold an inverted pan by its handle over the steam at some distance from the boiling water. Observe the inner surface of the pan. Do you see any droplet of water there? Yes, because water is changes into water vapor, then condenses and again change into water droplets. So it is also a type of physical change. One more activity is given, activity 6.5. Hold a used hacksaw blade with the pair of tongue. Keep the tip of the free end of the blade on the gas stove. Wait for a few minutes. Does the color of the tip of the blade change? Remove the blade from the flame. Observe the tip once again after some time. Does it get back its original color? So in activity 6.1 and 6.2 above, you saw that paper and pieces of chalk underwent change in a size. In activity 6.3 and 6.4, water changes its state from solid to liquid and from gas to liquid. In activity 6.5, the hacksaw blade change color on heating. So properties as shape, size, color and state of a substance are called its physical properties. So a change in which a substance undergoes a change in its physical properties is called physical change, and a physical change is generally reversible. In such a change, no new substance is formed. So we can say that what are the characteristics of physical change? During a physical change, only physical properties such as size, shape, color and state change. During a physical change, no new substance is formed, and generally physical change is reversible. No overall energy change take place, and chemical composition of a substance remain the same during the physical change. So this is all about the physical change, and we can give some more example of physical change like grinding of a substance, expansion or contraction of substances on heating and cooling, melting of wax, formation of clouds, and hammering of metal to form thin sheet, like hammering aluminum metal to form aluminum foil, and stretching metal to form wire, like hammering copper metal to obtain copper wires. So these are the example of physical changes. So we can say that in physical change, no new substance is formed, only physical properties are changed. Now next change is chemical change. A change with which you are quite familiar is the rusting of iron. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance. This substance is called rust, and the process is called rusting. Iron gate of park or farmlands, iron benches kept in lawns and gardens, almost every article of iron kept in the open gets rusted. At home, you must have seen shovel and spades getting rusted when exposed to the atmosphere for some time. In the kitchen, a wet iron pan gets rusted if left in the state for some time. Rust is not iron, it is different from iron on which it gets deposited. Let us consider a few more changes where new substances are formed. So students, what is chemical change? A change in which one or more new substances with entirely different chemical composition and properties from the original substances are formed is called chemical change. And let us perform some activity to understand the characteristics of chemical change. So in activity 6.6, to be demonstrated by the teacher. It is dangerous to look for long at the burning magnesium ribbon. The teacher should advise children not to stare at the burning ribbon. So what we have to do in this activity? Get a small piece of thin strip or ribbon of magnesium. Clean its tip with the sandpaper. Bring the tip near a candle flame. It burns with brilliant white light. As you can see in the figure 6.3, magnesium ribbon burning with the brilliant white light. When it completely burnt, it leaves behind a powdery ash. Does the ash look like the magnesium ribbon? The change can be represented by the following equation. Magnesium, the symbol is Mg, plus oxygen O2, and product is forming here magnesium oxide, that is MgO. The equation here are different from those in mathematics. In equation of this kind, the arrow implies becomes. No attempt should be made to balance chemical equation at this stage. So students, in this activity, in this equation, we can see that magnesium is reacting with the oxygen and forming the product magnesium oxide, that is completely different from the reactant, that is magnesium and oxygen. So we can see that new substance is forming here, that is magnesium oxide. Collect the ash and mix it with a small amount of water. Stir the mixture aqueous solution well. Test the mixture with blue and red litmus paper. Does the mixture turn red litmus blue? Does the mixture turn blue litmus red? On the basis of this test, how do you classify the aqueous solution, acidic or basic? On dissolving the ash in water, it forms a new substance. This change can be written in the form of the following equation, that magnesium oxide plus water, that is H2O, and product is forming here magnesium hydroxide, that means magnesium oxide and water is reacting together and magnesium hydroxide is forming. As you have already learned that in chapter 5, magnesium hydroxide is a base. So when we are using this magnesium hydroxide for testing the nature, that is acidic or basic, will come to know that when we are using a red litmus, it is turning into blue. So we can say that the nature of the solution is basic. So magnesium oxide is a new substance formed on burning of magnesium. Magnesium hydroxide is another new substance formed by mixing magnesium oxide with water, and it is basic in the nature. Activity 6.7 to be demonstrated by the teacher. In this activity, what we have to do, dissolve about teaspoonful of copper sulfate, that is blue pitral or Neela thotha, in about half a cup of water in a glass tumbler or a beaker. Add a few drops of dilute sulfuric acid to the solution. You should get a blue colored solution. Save a small sample of the solution in a test tube or a small glass bottle. Now drop a nail or a used shaving blade into the remaining solution. Wait for half an hour or so. Observe the color of the solution. Compare it with the color of the sample solution saved separately. Do you see any change in the color of the solution? Yes. You can see in the figure 6.4, the color is completely changed. You will observe that blue color of copper sulfate solution changes into light green color solution, and brown deposit is formed on the iron nail, or we can say on the blade. You can see in the figure 6.4, the blade is covering with the brownish deposition. So these changes are due to a chemical reaction between copper sulfate solution and iron nail, which produces two new substances, iron sulfate and copper. The iron sulfate solution is green in color, whereas the brown deposit on the blade is of copper. So this change can be written in the form of copper plus iron, then forming iron sulfate solution, copper sulfate solution plus iron, then iron sulfate solution is forming here plus copper, that is brown deposit. So we can conclude that from this activity we can conclude that during a chemical change the composition of the substances taking part gets completely changed. New substances are formed and the change is irreversible. Change in color take place also. So this is all about the chemical change. So what is chemical change? In chemical change, the new substance is formed and mostly it is irreversible and the chemical composition is changed. So students, one more activity is given, that is activity 6.8. Take about teaspoonful of vinegar in a test tube. Add a pinch of baking soda to it. You would hear a hissing sound and see bubbles of gas coming out. Pass this gas through freshly prepared lime water as shown in figure 6.5. What happened to the lime water? The change in the test tube is as follows. Vinegar, that is acetic acid, plus baking soda. Then they are reacting together and forming carbon dioxide and other substances. And the reaction between carbon dioxide and lime water is as follow. Carbon dioxide, that is CO2, plus lime water, that is CaOH2, then calcium carbonate CaCO3 is forming plus water. So you can see in the figure 6.5 set up to pass the gas through the lime water. So when carbon dioxide is passed through the lime water, calcium carbonate is formed, which makes the lime water milky. The turning of lime water into milky is a standard test of carbon dioxide. So you will use it in a chapter 10 to show that the air we breathe out is rich in carbon dioxide. So in activity 6.6 and 6.8, you saw that in each change, one or more new substances were formed. In activity 6.6, the ash was the new substance formed when magnesium was burnt in air. In activity 6.7, the reaction of copper sulfate with iron produced iron sulfate and copper. Both of these are new substances. Copper was deposited on the shaving blade of iron. In activity 6.8, vinegar and baking soda together produced carbon dioxide, which turned lime water milky. So can you name the new substance formed in this reaction? So we can say that the chemical change is which one or more new substances are formed is called chemical change, and a chemical change is also called chemical reaction. So new substance with entirely different chemical properties are formed from the original substance. So all of these are chemical changes, and a chemical change is also called chemical reaction. So the process by which one or more substance transform into new substances having entirely different properties from the original substances is called chemical reaction. Thus a chemical reaction occurs during a chemical change. And students, the substances which react with each other to form new substances are called reactants, and the new substance formed after chemical change are called products. But how do the substance changes into other substance, and why do the new substance formed after chemical change have different physical and chemical properties because it is all due to the rearrangement of atoms. For example, when hydrogen react with oxygen, it forms water. So the atoms in the molecule of hydrogen and oxygen rearrange themselves. So this is all about the chemical change. Chemical changes are very important in our lives. All new substances are formed as a result of chemical change. For example, digestion of food in our body, ripening of food, fermentation of grapes, etc. happen due to series of chemical changes. A medicine is the end product of a chain of chemical reactions. Useful new material such as plastic and detergents are produced by chemical reaction. Indeed, every new material is discovered by studying chemical change. We have seen that one or more new substances are produced in chemical change. In addition to new products, the following may accompany a chemical change, that is heat, light or any other radiation may be given off or absorbed in chemical changes or chemical reaction. Sound may be produced, a change in smell may take place or a new smell may be given off, and a color change may take place and a gas may be formed. So let us look at some example. You saw that burning of magnesium ribbon is a chemical change. Burning of coal, wood or leaves is also chemical change. In fact, burning of any substance is a chemical change. So burning is always accompanied by production of heat. So students, we can see that what are the characteristics of chemical change. During the chemical change, one or more new substances are formed. Chemical changes are permanent. Thus, a chemical change cannot be reversed by simple physical method like evaporation. During a chemical change, net change in energy take place. A large amount of energy is either given out or absorbed in the form of heat or light. And during a chemical change, both the physical and chemical properties of substance are changed. So what are the differences between the physical and chemical change? We can say that in physical change, no new substance is formed. In chemical change, one or more new substances are formed. Physical change is a temporary change, but chemical change is a permanent change, and physical change easily reversible by simple physical method, but chemical change generally irreversible. So that is all about the differences between chemical and physical change. So in this video, we'll do this much. Thank you everyone.